A particle of mass m this is a particle of mass m. It is moving with a speed u. Let's take it. And there's another particle which is at rest with another stationary particle of mass m. If the incident particle is deflected by 90 degrees, so what will happen after collision is the incident particle will get deflected and the other particle, the lighter, heavier particle will get deflected. So here is what? Oh, show like this. So there's a particle. So let it be V1. The heavier particle will get deflected through an angle theta. Elastic collision steering. So now you have to ask question, sir, what makes, because you said like something to determine the direction of motion, we should take impulse momentum equation. For subatomic particles, I'm making clear. For subatomic particles, impulse momentum equation and quotient of restitution is not defined. They're meaningless quantity. So Newton's laws of collision are not applicable for subatomic particles. The behavior of subatomic particles is totally different what we study in classical mechanics. That's why we go for quantum mechanics. Why the quantum mechanics has come to explain such things? So why do they deviate? So we don't have any explanation in classical mechanics. So we'll shift ourselves to quantum mechanics. There quantum mechanics I can give suitable explanation. To conserve momentum and to conserve kinetic energy. Impulse momentum equation is not defined, but momentum is defined. Momentum is conserved and energy mass is conserved. Later on when we go to nuclear physics, we are going to discuss in detail, not just energy, the energy mass is conserved. Here we are confining to only the is telling elastic collision. So initial kinetic energy equal to final kinetic energy. Let's write equation. Momentum along x-axis. Any direction it is conserved. Since it's very easy to write equations along x-axis, I'm conserving it. So initial momentum, mu, final momentum, 2mv2 cos theta. Then along y-axis, initial momentum 0, mv1, squaring equation 1 and 2 and adding will eliminate what we have v1 also, v1, v2 and theta. There's the equation 1, equation 2 is there. So I need one more equation. I'll apply initial kinetic energy equal final kinetic energy. So mu square by 2 should be equal to mv1 square by 2, 2m v2 square by 2. Squaring and adding. First add square and add equation 1 and 2. Then theta will get eliminated. Then substitute that v1, v2 here. Then solve it. So squaring and adding. U square plus v1 square is equal to 2v2 cos theta whole square 2v2 sin theta whole square. So u square plus v1 square is equal to, this should be 4 v2 square. 4v2 square. Now call this equation 4. Solving now 4 and 3 will get v1 and v2. Sir, are you sure? Well, particle 1 will deviate? Yes, I'm very sure. Huh? Why they behave like that? Yes, we can't explain this in classical mechanics. So therefore, the quotient of restitution, all these things are not defined for collision of subatomic particles. Means, sir, how do I come to know what is a collision? If they say the word particles collide, then you should think in this way. Don't go for E and impulse momentum equation. So it is in detail nuclear physics we'll discuss. These are some numericals just I picked up here. Solve this, you'll get expression for theta. V1, V2. After getting V2, substitute here, you get the theta. Just simple idea, nothing to do that one. Very easy for you. Sir, why it should deviate like this only? Now, why not particle 2m moves along straight line? Then momentum will not be conserved, no? Are you able to make a guess of situation here? Particle 1 get deflected here. To conserve momentum, particle 2 orphan should move in fourth quadrant. Then only momentum along y-axis will be conserved. Particle 2, sir, why not particle 2 move like this? Let particle 1 go up, no problem. Then momentum along y-axis initially 0, finally should be 0. So therefore the particle 2 must deflect here. Let's take now. This is some very important. Yeah.
Sir, how did you get the fourth equation?
Squaring and adding 1 and 2.
Okay.
Squaring and adding equation 1 and 2, u square plus v1 square equal to 2v2 cos theta whole square, 2v2 sin theta whole square. Do calculation and I'll proceed to the next idea. Now, a particle of mass m moving with a velocity u is incident on another identical particle of mass m which is at rest. Find the nature of collision if theta 45, 60 and 30 degrees. This is very important information I am sharing with you. For these three cases, we have to analyze here. First, theta 45 degrees. So we'll do one thing, just we'll get an expression for find the nature of collision is telling. What shall I do? If kf equal to ki, it will be elastic. Kf not equal to ki, it will be inelastic. So let me assume theta first case, theta equal to 45 degrees. There's a diagram initially. A very simple problem, no mathematics, nothing, just only you have to did everything question part. I'll answer. Let me start from here. First case, theta 45 degrees. Particle 1, it moves. It will collide with another particle which is at rest. After deflection, after collision, they will deflect. Both are at rest. After deflection, the first and second particle will be moving like this. So now apply conservation of momentum. mu should be equal to mv 2mv cos 45. U is equal to 2v by root 2. What is v is equal to? U by root 2. Now check initial kinetic energy. Mu square by 2. Final kinetic energy will check it. 2m v square by 2. So this is m u by root 2 whole square. So mu square by 2. So what we got it? Final kinetic energy is equal to initial kinetic energy. So therefore, when theta equal to 45 degrees, what is the nature of collision? Elastic collision. And then put theta equals 60 degrees. Just we have to put theta equals 60 degree, again conserve momentum, again write, again final, calculate the final speed. Why they will have same speed? Because they are deflecting symmetrically with respect to initial line of motion. That's what I assume. Sir, how do you can say? Now, let me discuss three cases. Then you have to ask a question like, sir, which one will occur practically? Let's discuss all three cases. Then we'll come back and we'll see that, sir, which one actually practically, which one will occur is what we have to ask ourselves a question. The velocity here in this case, yeah, let it be v only, no problem. Do calculation. Now 60 degrees it is. Initially particle 2 is at rest. This is 1, this 2. So mu is equal to 2 mv cos 60 degrees. U equal to v from this. Then initial kinetic energy is mu square by 2. Final kinetic energy is 2 mv square by 2. M u square only. Look at final kinetic energy. Less than, greater than initial kinetic energy. How it is possible? Yes, it can happen. Subatomic particles, it can happen. Maybe what happened? The particle 2 may be at higher state, go back to atomic structure. So due to collision, what will come to lower state, and the energy available what will be converted into kinetic energy of the particles. This can be atom. The particle 1, let it be a 1 be particle, 2 let it be some atom which is at higher state, due to collision comes to lower state, or 1 may be atom, 2 may be the particle, anything it is. So kf greater than ki. So what is the nature of collision now? Inelastic, theta 60 degrees. No, last one, theta 30 degrees here. These are the very troublesome ideas for students, because we are just only in classical mechanics is what you are being taught till now. So in our the whole physics, as we proceed now, we'll end up with some question marks. We are unable to answer few of the things that can be answered only in using quantum mechanics. So like when we go for modern physics now, there almost every topic will end up with a question mark. Even in Eaton thermodynamics, we'll end up with a question mark. Then how to answer them? That will lead to a quantum mechanics. Then applying conservation of momentum, mu equal to 2mv cos 30 degrees. So u is equal to v root 3. Then initial kinetic energy mu square by 2. Final kinetic energy 2mv square by 2 m look at final kinetic energy should be less than. So if the deflecting angle is less than 90, kf less than ki. If the deflecting angle is greater than 90, kf will be greater than ki. If deflection angle between the colliding particles, if it is equal to 90 degrees, it will be elastic collision. Now your task question, sir, is it same particle? Yes. Let me show complete. I think okay, yeah, fine. This much, yeah. All three cases are there. First time, the first sequence, I'll send a particle 1 which will collide with identical particle 2 which is at rest. They'll get deflected. The deflection angle between them will be 90 degrees and they deflect symmetrically with respect to initial momentum of first particle. Then I get elastic collision. Now the same particle again, I'll repeat this event. I'll repeat this event. Then when I repeat this event, what we get is, they'll get again, they collide, they'll get deflected where the deflection angle between them is 120 degrees and they deflect symmetrically. Then the collision will be inelastic. Now the same particles again, I'll repeat. Then it may happen like this. So then means now like a question comes like a, how do I come to know like a which collision it occurs? We can never predict in collision of subatomic particles that what will happen. Practically what happens, collision occurs and after collision we have to make observation, oh, this is what it happens here. Means now when particle 1 goes and collides with particle 2, what can happen? Sir, event 1, event 2 or event 3, any one. This is something very abrupt way of the physics what you are seeing now. Because till now the physics what is saying some definite rule, no? And somebody is saying that exchange of velocity, they are particles. And it can happen that particle 1 will collide with particle 2, exchange of velocity occurs, particle 1 will come to rest and particle 2 will move horizontal. It can also happen. Fourth case I'm bringing. Even this is also possible. It's a test after collision. M1 will be at rest. This is also possible. Exchange of velocities, add-on. The collision may be add-on, the collision may be two-dimensional, the collisions will be elastic, the collision will be inelastic. So altogether, 4 possibilities are there. So we can never predict how do they collide? They collide and after collision, looking at the practical things, then we should conclude here, oh, this is what happened here. I think this is something totally against the physics till now what you learned. Because what is the constraint? The classical mechanics is unable to explain this. Then quantum mechanics will definitely help us a lot. In account to quantum mechanics, yes, I can justify that why only it happened here. Classical mechanics is unable to answer. See, nobody can answer. No, the knowledge what you have, very strange thing for us. The knowledge what you have now. So what do you say that one? So how it is possible? 1, 2, 3, 4. Anyone can occur. So the reason for this is quantum mechanics. This was the failure of classical mechanics here. Got the idea, no? So when collision of particle comes, you be alert. Any of